So this is an optional screencast for people who want help going through the practice test. Okay, so let's find the slope of the line tangent to the graph of f of x equals 2 over x at the point 1, 2. Alright, so the way we're going to start that is we're looking for the point that's tangent to the graph, so we're wanting instantaneous, and here is our function, so that's the two important parts. Alright, so since we're using the tangent, we're going to use our slope equation. And let's see, as the limit as h approaches 0 of f of x plus h minus f of x all over h. So we want to plug in 1, right? So here's the point. So we're going to plug in 1 for x. Okay, so the limit as h approaches 0 of f of 1 plus h minus f of 1. 1 plus h over f of 1 all over h. Okay, so we have to plug this into the function. So I'm plugging 1 plus h everywhere there was an x. So this means I'll have 2 over 1 plus h, and I'm subtracting f of 1. So f of 1 is 2 over 1. Alright, because 2 over 1 is just equal to 2, so I just wrote 2 there. Alright, well, and all of this is over h. So I need to make a common denominator. So I'll multiply over here. Well, actually, I only have to over here. 1 plus h over 1 plus h. Common denominator of 1 plus h on the bottom. Then we'll have 2 minus 2 times 1 plus h, and this is all over h, and we're taking the limit as h goes to infinity. Alright, so let's go and let's distribute this out. So I have the limit as h goes to infinity, 2 minus 2h over 1 plus h. Instead of dividing by h, I'm going to multiply by the reciprocal, which is 1 over h. Okay, 2 minus 2 is 0. So I'll be left with negative 2h over 1 plus h, because that part goes away, so I cross out these h's. Limit as h goes to 0 of negative 2 over 1 plus h. So as I plug in 0, it's just negative 2 over 1, which is negative 2. Awesome. Okay. Cool. So that's it. Find the slope of the graph. Well, I mean, I could show an intermediate step. Limit as h goes to infinity, just to make sure people were groovy with what I was doing. So after I crossed these guys out, I was left with the following, and then I cross out, and then I get this. Okay, find the slope of the graph at any point. Okay, so we're still wanting the slope at a point, but it's not a specific x value, it's at any x value. So once again, we'll use the limit as h goes to 0 because we're trying to find the instantaneous velocity, but the difference is, since it's at any point, we don't want to plug in a value for x. Okay. So let's see, x squared minus 3x, that's my f of x. And the first one, when I'm trying to plug in x plus h, I have to plug in x plus h into direct substitution into both places where x is written. So I will have x plus h squared minus 3 times x plus h. Subtracting f of x, so that's straight up just the function. All over h, right? Go over it again. Alright, so we have to FOIL the x plus h out. So I have x squared plus 2xh plus h squared minus 3x minus 3h minus x squared plus 3x, right? Because I was distributing this negative out. Distribute the negative 3 out, so that's how I got that. All over h. Okay, let's see if anything cancels. Plus 3h minus 3h minus x squared plus x squared. Okay, And then let's keep going. Limit as h goes to 0. I'm going to pull out an h as I write it, plus h minus 3 all over h. Cancel out these h's. Limit as h goes to 0 of 2x plus h minus 3. As you plug in 0 for h, you get 2x minus 3. And this is the slope of the graph at any point. So I could pick any x value to plug in, and this is what I would get. So I'm going to be very clear. This is what is expected. There is a shortcut way of finding the derivative using the power rule, which some tutors taught people last year, but that's not the point of this lesson. Using the basic definition of a derivative is the point of the lesson, and this is how I want you to do it. All right, the position s of an object in miles after t minutes is given by this function. Find the average velocity between time 1 and time 5. So the average velocity, let's see, our slope is going to be s of t2 minus s of t1. Maybe I should write this. V average is literally just our regular slope equation over t2 minus t1. Okay, so this is going to be s of 5 minus s of 1. It's an s. Ooh, super hard to see. Over 5 minus 1. Alright, so s of 5. I can literally find what s of 5 is, s of 1, and then plug in. So let's see, 5 times 2 is 10, minus 13 times 25. So if I have 13 quarters, that's going to be $4.25. So 10 minus 4.25 is going to be, wait, did I do it around 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, $3.25. $3.25. So I'm subtracting, let's see, negative 315. Okay. S of 1. 2 times 1 is 2, minus 13 is going to be negative 11. Okie dokie. So I have negative 315 minus negative 11 over 4. So this is, let's see, add 11, so it's negative 304 over 4. Divide that guy by 4, you get negative 76 miles per minute. Average, well, it doesn't say. Just say, miles, minutes. Okay, so it is. Negative 76 miles per minute. Okie dokie. Find the instantaneous rate, instantaneous velocity at t equals 3. Okay, so this is using the function from up above. But we want the instantaneous, so this is when we use the limit, because we want to see as h goes to 0 what's happening with our function. Alright, so t plus h minus s of t all over h. Here, this is our t, so we're plugging that in. So the limit of, we'll write it here to be clear about what we're going to be doing. So this is the limit of s of 3 plus h minus s of 3 all over h. Alright, so we got to plug, let's see, our function, we should write it down here. 2t minus 13t squared. So s of t is equal to 2t minus 13t squared. So okay, we're plugging in the 3 plus h, this guy. Plug it into both of these t's. So 2 times 3 plus h minus 13 times 3 plus h squared. And we're subtracting s of 3. Okay. 2 times 3 minus 13 times 3 squared all over h. Distribute this 2 out. So I have 6 plus 2h minus, okay, so 9 times 13 is going to be 117. Yeah, 117. Minus 117, 6, 60, 78, minus 78h, minus 13h squared, minus 6, 3 squared is 9, 90, 117. This is going to be a plus 117 because we're distributing the negative. Distribute the negative. Distribute the negative after you FOIL. Okie dokie. Negative 117 plus 117. Minus 6 plus 6. 6. Okay, yeah, the number's right. Okay, so we're left with the limit as h goes to 0 to h minus 70. Ooh, why don't I simplify this? 2 minus 78 is going to be negative 76h minus 13h squared over h. Okay, so let's see. 2 okay, so cross out the h's and we're left with the limit as h goes to 0 of negative 76 minus 13h. Plug in 0 for h, you get negative 76. And this is, remember, it's negative 76 miles per minute. So coincidentally, it turns out the average velocity between 1 and 5 seconds is the exact velocity at 3 seconds. Crazy. Fireworks are launched at upward velocity 90 feet per second. Suppose the height of the fireworks after they're launched is this. We want to find the instantaneous velocity of the fireworks. Instantaneous means we're going to be using our equation with limit. Alright, so here is our instantaneous velocity. We want to plug in the t plus h because it didn't say at a certain time. It just wants the instantaneous velocity, so we're going to assume they just want the equation. So, a little bit more difficult, because everywhere where we see a t, we're going to be plugging in t plus h. And then this right here is just going to be whatever the equation was. Okay, so negative 16 times t plus h squared plus 90 times t plus h plus 3.2. And we're subtracting literally the exact equation. Okay, over h. This one's a little longer, but it's fine. So, negative 16 t squared minus 32 t times h. Because if you take t times h and square it, it's t plus h times t plus h, so you get t squared plus th plus th plus h squared. So when I multiply t squared by negative 16, you get negative 16 t squared, and then this is 2 th times negative 16 is negative 32 th. Just make sure we are groovy with where all this is coming from. Okay, distribute the 90. So plus 90t plus 90h plus 3.2. Yay. Okay, distribute this negative out. Plus 16t squared minus 90t minus 3.2 all over h. Alright, favorite part, cancel this out. Positive 3.2 negative. Negative 90t, positive 90t. Plus 16t squared minus 16t squared. Cool. That's how you know you did it correctly, is because your actual function, everything with just a t should go away, and you should be left with everything that's left should have a h as a factor because it's going to be canceling out. Yeah, I can't cancel anymore. Okay, good. Plus 90h over h. Go through cancel. 1h every term. Okay. Limit as h goes to infinity of negative 32t minus 16h plus 90. So what we get at the end is, once we plug in 0 for h, it's going to be negative 32t plus 90. Awesome. And that's it. That is our equation. And now we want the velocity at 0.5 seconds after they're lit. So this is the instantaneous, but luckily we already have an equation for it. So you just have to plug in 0.5 for t, and that's going to be our instantaneous velocity. So this is going to be 74 feet per second. And because, so kind of makes sense that the upward velocity is 90 feet per second, because if we're trying to find the velocity anytime, here's our v naught, and this is acceleration times time. Whatever. If you're not taking physics, don't worry, but this will pop up later for you. Since we found an equation for instantaneous velocity at any moment, I could have you plug in 1,000 different time values and you could get a slope for every single point. Alright, given the curve, blah blah blah, at what x values will there be a horizontal tangent? Ooh, okay, so tricky. Horizontal tangent, if you think about it, if we have a horizontal line, and that is the tangent, that is the slope of a horizontal line is 0, aka, for which x values is our slope going to equal 0? So the first thing I need to do is find the equation of the slope. I need to find expression for the slope. Okay, so let me have a little smaller of a pen. Okay, so I want to take the limit as h approaches 0 of f of x plus h minus f of x all over h. So what this is going to be, so I'm going to leave everything in terms of x. This first one, I'm plugging in x plus h. Everywhere there's an x. So I have 2 times x plus h cubed minus 3 times x plus h, put brackets, and I'm subtracting f of x. So that's just going to be 2x cubed minus 3x. And this is all over h. Alright, trig play is actually the cube. So we know x plus h times x plus h is going to give x squared plus 2xh plus h squared. But that's only x plus h squared. So I have to multiply this one more time by x plus h in order to get the cube. Okay, so x cubed plus 2x squared h plus x h squared. So I'm going to write it so my x's are always first when I have an x and an h. That way I can combine anything that's like terms. Okay, plus x squared h, now I'm distributing the h out, plus 2x h squared plus h cubed. Okay, let's see if we can combine any like terms. Okay, so I have x cubed, x squared, okay, x squared h, x squared, x squared, x squared h, x squared, x, nope, okay. So this is going to be plus 3x squared h, x h squared, x, okay, so plus 3x h squared, and then plus h cubed. So if you know the binomial expansion, I don't know if we teach it to the at-levels, but there is a binomial expansion. It's using Pascal's triangle. Whatever, not important. Okay, so let's fill this out. So I have the limit as h goes to 0 of 2 times, I'm just going to rewrite this, just so it's down here and we know what we're multiplying by. Okay, minus 3 times x plus h, okay, minus 2x cubed 3x, alright, all over h. Not necessarily not a necessary step, but I just want to make sure we're all good. So I'm going to distribute the 2. So the limit as h approaches 0 of 2x cubed plus 6x squared h plus 6x h squared plus 2h cubed minus 3x minus 3h minus 2x cubed plus 3x all over h. Alright, let's see if anything cancels. So I have a minus 3x plus 3x, 2x cubed minus 2x cubed, and can I simplify? No, nothing else will combine. Okay, so let's just rewrite what we have. Set the limit as h goes to 0 of 6x squared h plus 6x h squared plus 2h cubed minus 3h all over h. So there should be an h in every term. Okay, so I factored out, canceled, and now I'm left with 6x squared plus 6xh plus 2h squared minus 3. If I plug in a 0 for my h's, plug in 0, I'll have 6x squared minus 3 is my expression. But remember, that's not what we're looking for. We found the expression, but we want to know, where is this equal to 0? Where do we have a horizontal tangent that's equal to 0? Okay, so this is the expression for finding the instantaneous, the slope of our tangent. But where is this equal to 0? So let's go over here. So 6x squared minus 3 is equal to 0. Add 3 on both sides, divide by 6 is 1/2. Take the square root, so don't forget it's going to be plus or minus the square root of 1/2, which is going to be, plus or minus 1 over root 2. Well, we've dealt with this before. Plus or minus root 2 over 2. So these are the two values where our horizontal tangent will be equal to 0. So those are the two x values. This is the answer. So that's a tricky question, but very typical for a calculus question. All right, find the average rate of change over indicated interval. So this is some extra practice. So average rate of change here, you just have to pay attention to the keywords. So average, we're just using the regular slope equation. So f of x2 minus f of x1 over x2 minus x1. So this is going to be f of 3. Ooh, this should be f of 3 minus f of 1 over 3 minus 1. I like doing my work down here because otherwise it gets pretty messy writing everything up above. 3 squared plus 1, so 27 plus 1 is 28. F of 1, 1 squared, 1 cubed, so 1 plus 1 is 2. So I have 28 minus 2 over 2. 26 over 2 is 13. And we don't have the units. Alright, so next one, we have our equation, which is sine of x. And once again, we're trying to find the average rate of change. So I'm just going to use our regular slope equation. F of our second x value minus f of the first x value over time 2 minus time 1. So I'm just going to write, I'm not going to do it separate. I'm just going to write it right here. Sine of pi over 6 minus sine of 0 over pi over 6 minus 0. Okay, that's just pi over 6. So pi over 6 is 1/6 of 180, so it's 30 degrees. Sine of 30 degrees, 30, 60, 90, hypotenuse 1, 1/2, root 3 over 2. Okay, so sine is opposite over hypotenuse, so it's 1/2. Sine of 0, so this is a quadrantal. Sine is the y, so 1/2 minus 0 over pi over 6. So you get 1/2 over pi over 6 dividing by a fraction is the same as multiplying by the reciprocal. So this is just going to be 3 over pi. And that's it. Okay, so this is very similar to a problem we've done before. Alright, it's last page. Use this function, find the slope of the tangent at 3. So we're looking for the slope of the tangent. This is very similar to a problem before. So I'm just going to pause and write the solutions. Let me know if you have questions. So this is very similar to the problem we did before. I just did a real quick shortcut to make a common denominator. I said, well, 3 over 3 is the same thing as 1. So I could replace it with another equivalent expression of 1, which is 3 plus h over 3 plus h. That's a little shortcut, so that way we have the same denominator. And now that we have the same denominator, you have 3 minus h. So I simplified and just went straight to negative h since 3 minus 3 is 0. And then also, instead of dividing by h, I multiply by the reciprocal, which is 1 over h. Cross that out is what you get. Plug in 0 for h, and you get negative 1/3. Okay. Last two questions. So f of x is equal to x squared minus 6x. Find the slope at any point means an expression in terms of x. And then at what value will it have a horizontal tangent, aka horizontal tangent means the slope is equal to 0. So these are more the level of questions that you'll be expected to be able to just plow through next year in calculus. So we want the slope at any point, but notice it's a point, not average. So we have to use the function, we have to use the tangent approximation, which uses the limit as h goes to infinity. It goes to 0, All right, so we have x plus h minus f of x all over h. So we need to plug in x plus h everywhere there's an x. Limit as h approaches 0. So we have x plus h squared minus 6 times x plus h. And there's a reason why I use brackets and parentheses, because then you won't forget to distribute your negative. And then you'll get the problem correct, instead of having to only get partial credit. So let's go ahead and simplify this out. X squared plus 2xh plus h squared minus 6x minus 6h, etc. Do not forget to distribute that negative out on the second part, all over h. Okay, so it's the same process every time. Your regular functions should cancel. So you see how we have an x squared and a negative x squared. We have a negative 6x and a positive 6x. That's on purpose. You'll know you're on the right track if everything without an h goes away, because we want to cancel out the h that's on bottom, so everything that's left should have an h. That's the process, and that's the flow. Easy way to check if you did it correctly. Okay, so at the end I have 2x plus h minus 6, and as h goes to 0 we have 2x minus 6. So that is the expression that we're left with. 2x minus 6, and then we want to know at what x value will we have a horizontal tangent. Okay, so when the slope is equal to 0, so you set 2x minus 6 equal to 0 and solve for the x value that would make the slope be 0. So we see that would be an x value of 3, and that's it. So if you understand all of these practice tests and the extra practice, you will be ready for the test.